Let's kick things off with a quick overview of DevOps. It's really about bringing development and operations teams together, breaking down silos that used to cause delays and frustrations. Think of it as building software faster and more reliably. A core idea is continuous integration, getting code changes into the system frequently for testing. Then we have continuous delivery, which automates the release process so updates get out to users much quicker. Finally, infrastructure as code ensures our infrastructure itself is managed through code, making things repeatable and predictable. And of course, constant monitoring and feedback are vital for improvement. Okay, let's talk about how these approaches to software development stack up against each other. Traditionally, things moved in a very linear fashion. You plan everything up front, build it, test it, and then deploy it. It was often a slow process with lots of handoffs between teams, which could lead to problems down the line. Agile came along as a better alternative, focusing on short cycles, constant feedback, and working software delivered frequently. But even with Agile, there could still be friction between development and operations. Then, DevOps emerged. It's really about blurring those lines and fostering a culture of collaboration and automation across all stages of the process, from coding to deployment and monitoring. Okay, let's talk about continuous integration. It's a really important part of how DevOps teams work. Basically, CI is all about merging code changes very frequently. Imagine developers making small, manageable updates several times a day and automatically building the project with every single commit. This involves compiling the code, running automated tests, and creating deployable packages, all without human intervention. The goal is to get rapid feedback on those changes, quickly spotting any problems that might have slipped through. CI helps reduce risk by finding bugs early, improves the overall quality of the software, and ultimately speeds up how quickly we can deliver new features or updates to our users. Okay, let's talk about continuous delivery and deployment, often shortened to CI/CD. Think of it as a streamlined way to get your software updates into users' hands more frequently and with less risk. The first step is continuous integration. This means developers regularly merge their code changes, and the system automatically builds and tests everything. Then we move on to continuous delivery, where the process ensures that every change is always ready for release. And finally, continuous deployment takes it a step further, automating the actual deployment to production without any manual steps. Let's talk about infrastructure as code. Basically, it's all about treating your infrastructure, servers, networks, the whole shebang like software. Instead of manually clicking around in a cloud console, you write code to define and provision everything. This means automation, better consistency, easier rollback if something goes wrong, and even helps you manage costs more effectively. It's a huge shift from how things used to be done. Okay, let's talk about infrastructure as code. Basically, instead of manually setting up servers and networks, which is a huge pain, we write code that defines our infrastructure. We'll be looking at three popular tools: Terraform, CloudFormation, and Pulumi. They all do the same job, automating how we build and manage our systems, but they approach it differently. Terraform's great if you need to work across multiple cloud providers. AWS CloudFormation is super strong when you're only using Amazon Web Services, and Pulumi uses languages like TypeScript or Python, which can make things easier for developers. Okay, let's talk about configuration management tools. They are a core part of any DevOps engineer's toolkit. Basically, these tools help us automate how our servers and systems are set up and maintained. We've got four popular options: Ansible, Chef, Puppet, and SaltStack. Ansible is really easy to pick up because it doesn't require agents on the machines you're managing, it just uses SSH. Chef uses Ruby for its configuration language and has a client-server setup. Puppet relies on a declarative language and uses an agent. And then there's SaltStack, which is built with Python and focuses on event-driven automation. Okay, let's talk about containers. Think of them like a super efficient way to package up your applications. Docker is the most popular tool here. It bundles everything an app needs: code, libraries, and settings into a single unit called a container. This means no matter where you deploy your application, whether on your laptop, in the cloud, or anywhere else it'll run consistently because all its dependencies are included. Containers offer huge advantages. They are portable, meaning they can run just about anywhere. They are much more efficient than traditional virtual machines, using fewer resources, and you can easily scale them up or down as demand changes. Key things to remember are images, those read-only templates, containers which are the runnable instances of those images, and Docker Hub, a central place to store and share container images. Okay, let's talk about Docker. Essentially, it's a way to package up your applications and all their stuff like libraries and tools into something called a container. Think of it as a little self-contained box that ensures your app runs the same way whether you're developing it on your laptop, testing it in a staging environment, or deploying it to production. This solves a lot of problems with compatibility and setup differences between environments. Docker helps make things much more portable, isolated for security, and generally uses fewer resources than traditional methods. Okay, let's talk about how Kubernetes works. Think of it as a super smart traffic controller for your applications. It's built around two main parts, the control plane and the nodes. The control plane is like the brain. It uses components like Kube API Server to manage everything. It also stores all of its information in ECD, which is like a super secure memory bank. Then there's the scheduler, deciding where each application should live, and the controller manager making sure things are running as they should. Finally, we have the nodes. These are our worker machines, each with a kubelet that watches over everything happening on it and a container runtime to actually run the applications and containers. Pods are really the smallest unit of deployment, essentially groups of related containers. Okay, let's talk about Kubernetes. The very basic building block is the pod. Think of it as a little container home for one or more containers that work together. Deployments are how we manage these pods, ensuring the right number are always running and automatically fixing any problems. Services provide a consistent way to access those applications, like a stable address. And finally, ingress acts like a traffic cop, directing outside requests to the appropriate service within your cluster, all handled elegantly by Kubernetes. Okay, let's talk about Kubernetes YAML manifests. They are really crucial for getting things running smoothly in a cluster. Think of them as the instructions your system uses to create and manage all your applications. Basically, these files tell Kubernetes exactly what you want it to build and deploy. We'll look at a simple example of a deployment manifest here. It defines how many copies of an application you want to run, and how they're matched to labels on the nodes. The API version tells Kubernetes which version of its API we're using. Kind specifies what type of resource this is, in this case, a deployment, and then there's metadata like the name and some labels that help organize things. Finally, the spec section outlines the desired state, how many replicas you want, and what image to use for each container. Okay, let's talk about Helm charts. They're seriously a game changer for deploying apps on Kubernetes. Think of them as deployment blueprints. They package everything you need to get your application running smoothly. Each chart is actually a directory with a few key files, a chart, YAML which tells you all about it, templates that define ***, how ***. The app gets deployed using Kubernetes resources like deployment and services, and a values, YAML file containing default settings, but you can easily change those to tailor the deployment. Helm simplifies things by hiding the complexity of Kubernetes itself, allowing for easier reusability and dynamic configuration. Okay, so Kubernetes is great at deploying and managing applications, but what happens when you need one service to talk to another? That's where service discovery comes in. Essentially, it's how a service knows where to find its pods, especially since those pods can be constantly scaling up or down. Kubernetes uses internal DNS. Think of it like an internal internet for your cluster, and this DNS automatically registers services with hostname-based addresses. Different service types expose these services in different ways, like exposing them directly on a node's port or using a load balancer. At the heart of it, kubedns or core DNS are the cluster's DNS servers. They handle all those lookups for you. So, when your application needs to talk to another service, it just uses the service name and the port, and Kubernetes handles the rest. Okay, so when it comes to running containers effectively, let's talk about some key best practices. The first thing is thinking about how you define your infrastructure. We want a declarative approach, meaning you describe the asterisk end result asterisk you want, not the steps to get there. Then, using infrastructure as code allows us to treat our entire setup like code, making it easier to manage and track changes. We also want to ensure we're building containers from scratch for each deployment. This is called immutable infrastructure. Finally, automation is key. Rolling updates allow us to deploy new versions without downtime, and easy rollbacks are essential if something goes wrong. Don't forget monitoring. Tools like Prometheus can give you a great overview of what's happening. Okay, so let's talk about the tools you'll actually be using as a DevOps engineer. We have a bunch of really good options out there for automating your builds and deployments. Jenkins is the old guard, super powerful and flexible, but it can take some time to get up and running right. GitLab CI is fantastic if you're already using GitLab because it's built in and very straightforward. Azure DevOps is Microsoft's complete platform, offering everything from planning to deployment. And finally, Circle CI is a really easy to use cloud solution, great for smaller projects or teams that want something simple and quick. Okay, let's talk about pipeline as code. Basically, this is a really powerful way of thinking about how we build and deploy our software. Instead of clicking around in a graphical interface to set up our CI/CD pipelines, we actually write the instructions for those pipelines using things like YAML or JSON and store them in version control just like any other code. This brings a ton of advantages. It makes sure everyone's on the same page, we can easily track changes over time, and most importantly, it makes our deployments incredibly reliable because they are fully automated and reproducible. Okay, let's talk about Jenkins files and how they're changing the game in DevOps. A Jenkins file is essentially a recipe for your entire automated workflow. It tells Jenkins exactly what to do, from building your code to deploying it. Now, there are two main ways to write these files: scripted and declarative pipelines. Declarative pipelines are the newer, more popular approach. They are easier to read and understand because they focus on asterisk what asterisk you want to accomplish rather than asterisk how asterisk. Think of it like giving Jenkins a set of instructions instead of writing detailed code step by step. They provide some really great benefits, including making your pipelines much easier to maintain and reducing the chances of errors. And as you can see in this example, they are incredibly readable. Even if you're not a coder, you can quickly grasp what each part of the pipeline is doing. Okay, let's talk Git. It's absolutely crucial for any DevOps engineer. Basically, Git is a system that helps you track all the changes you make to your code over time and allows multiple people to work on the same project without stepping on each other's toes. Some fundamental commands are git init to start a new repository, git clone to copy an existing one, git add to tell Git which changes you want to include, git commit to save those changes with a message, and finally, git push to upload your work to the cloud. Now, branching is super important. Branches allow you to create separate lines of development for new features or bug fixes. There are several popular strategies like Git Flow, which has a stable main branch, and feature branches, GitHub Flow, which is simpler with just one main branch, or trunk-based development where everyone commits directly to the main branch. The best strategy really depends on your team's needs and how they work together. Okay, let's talk about version control. As a DevOps engineer, you need to understand how VCS work. GitHub is the big one, super popular and great for open source projects and working with others. GitLab is another powerful option that combines repository management with CI/CD pipelines. It's like a complete DevOps platform. And Bitbucket is really good if your team already uses other Atlassian tools like Jira. Basically, choosing the right VCS depends on what works best for your team. Okay, let's talk about build tools. These are absolutely crucial for any DevOps engineer. Think of them as the engine that drives your software creation process. We've got a few big players here. Maven, which is super popular for Java projects, using XML to manage everything. Gradle, a really flexible option that supports many languages and uses Groovy or Kotlin scripts. Then we have NPM and Yarn, both used for JavaScript projects. NPM is the default, but Yarn offers some performance benefits. Knowing which tool best fits your project will make a huge difference in how smoothly things go. Okay, let's talk about artifact repositories. They are absolutely crucial for a DevOps engineer. Essentially, these are centralized places to keep all the building blocks of your software, things like compiled code, libraries, and even container images. We use them to avoid chaos in our development process, ensuring everyone is using the same trusted versions of everything. You'll often hear about Nexus and Artifactory are two very popular choices. Nexus is open source and really strong on security, while Artifactory is a commercial option packed with advanced features like replicating artifacts from different sources to speed things up and making sure only the right people can access sensitive components. Okay, let's talk about monitoring and logging. They are absolutely essential for any DevOps engineer. Think of them as the eyes and ears of your system. We'll be looking at a really solid stack of tools. Prometheus is our time series database, perfect for collecting all those metrics from our apps and servers. Grafana then takes that data and turns it into beautiful, easy to understand dashboards. We can spot problems right away. Then there's the ELK stack, Elasticsearch, Logstash, and Kibana. That's a powerful way to collect, search, and analyze all of our logs. And for newer projects, Loki is gaining serious traction as a lightweight alternative built on Prometheus' system. Okay team, let's talk about keeping a close eye on our infrastructure. It's super important that we know when things are going wrong before they affect the user experience. We have a few popular tools out there to help us with this. Datadog is really great for getting a complete picture of everything from your servers to your applications. New Relic is fantastic at pinpointing performance bottlenecks within your code, and Zabbix offers a lot of flexibility, especially if you've got some very specific monitoring needs. It's worth noting that they all have different strengths and weaknesses, so picking the right tool depends on what you need to monitor. Okay, so let's talk about application performance monitoring or APM tools. These are seriously important for any DevOps engineer because they give you a really clear picture of how your applications are actually performing from the user's perspective. We're looking at things like response time, error rates, and how much CPU and memory an app is using. There are some fantastic tools out there. Datadog, New Relic, Dynatrace, and App Dynamics are all popular choices, each offering a slightly different set of features. Basically, APM helps you spot problems before they affect your users, quickly figure out what's causing them, and then optimize the app to run as smoothly as possible. Monitoring is absolutely critical. Okay, let's talk about log management. It's seriously important for any DevOps engineer. Basically, you want to collect all your logs from across the whole system, your apps, servers, databases, everything, and put them in one central place. Think of it like a giant logbook that makes sense. Then, we need to make sure those logs are structured so they're easy to read and understand. JSON is a great format for this. We also have to manage how long we keep the logs. You don't want to fill up your storage, but you also need to be able to investigate issues that happened in the past. And finally, setting up alerts based on what's happening in those logs can give you early warnings of problems before they become major incidents. It's a continuous process of reviewing and improving, so don't just set it and forget it. Let's talk about how these major cloud providers fit into a DevOps engineer's toolbox. AWS is the veteran, offering an enormous selection of services. It's super mature and has a huge community to help you out if you get stuck. Microsoft Azure shines when you're already heavily invested in the Microsoft world, with great integration. And then there's Google Cloud Platform, known for its innovation, especially around data and containerization like Kubernetes. Each one has its own strengths. It's all about choosing what's right for your project. Okay, let's talk about how we use some key AWS services to build and automate our deployments. We've got EC2, that's your virtual servers, the base for running everything. Then there's S3, which is like a super scalable online storage space perfect for storing files and backups. IAM helps us control who gets access to what in the cloud, really important for security. VPC creates a private network so our applications are isolated and safe. EKS takes container orchestration to the next level, making managing those containers much easier. Cloud watches our eye in the cloud, keeping an eye on performance and letting us quickly spot any problems. And finally, Code Pipeliner automates the entire build, test, and deploy process, streamlining everything for faster releases. Okay, so when we're talking about DevOps with Azure, it's really important to understand these 4 key areas. First up are pipelines. Think of them as the engine that drives your continuous integration and deployment. Next, you've got repos, which is where all your code lives, hosted securely in Azure Repos Git. Then there's artifacts, a place to store and distribute those packages ready for your builds. And finally, boards. It's how your team plans, tracks progress, and collaborates on projects using the Agile methodology. Okay, let's dive into using Google Cloud for DevOps. We're going to look at 3 key tools: GKE, which is like a super-powered Kubernetes engine cloud build that handles automating your builds and deployments, and Stackdriver, providing crucial monitoring and logging so you can see what's happening with your applications in real time. Think of it as the whole pipeline working together seamlessly. Okay, let's talk about serverless computing. It's a really cool approach to building applications. It's all about letting the cloud provider handle the heavy lifting when it comes to managing servers. Think of it as no server development, but that's not completely accurate. You don't need to worry about provisioning or scaling infrastructure because your cloud provider takes care of all of that for you. It's event-driven, meaning your code only runs when something happens, like someone making a request to an API or a new piece of data arrives in a database. You pay only for the time your code is actually running, which can be a huge cost saver. There are several popular services out there like AWS Lambda, Azure Functions, and Google Cloud Functions. They each have their strengths, but they all share these core concepts: event-driven execution, pay-per-use pricing, and stateless functions. Okay, let's talk about serverless. It's a really cool way to build and run applications. Basically, it means you don't have to worry about managing servers yourself. The cloud provider takes care of all that for you. AWS Lambda is a core part of this approach. It lets you run code without having to manage any infrastructure. The serverless framework is your best friend here. It's a tool that makes deploying and managing these serverless apps incredibly easy, automating a lot of the tedious work. Think of it as your command line control panel for building and launching serverless applications. We'll cover some basic commands to get you started installing the framework, configuring your credentials, and deploying to a development environment. Okay, let's talk about how networking fits into DevOps. First up is DNS. It's basically the internet's phone book, translating website names into numbers that computers understand. Next, load balancing is all about distributing traffic across multiple servers to keep things running smoothly and handle lots of users. Then we have NAT, which helps your internal network connect securely to the outside world without exposing all your details. Finally, VPN creates a secure tunnel when you're working remotely or accessing sensitive information. Okay, let's talk about reverse proxies. Think of them as a gatekeeper in front of your servers. They handle all incoming requests from clients like web browsers and then forward those requests to the correct backend server. Why do we need these? Well, they're brilliant for distributing traffic across multiple servers so no single server gets overwhelmed. Plus, they can really boost security by hiding the details of your internal infrastructure. And they can even cache static content like images or CSS files, which helps speed things up. Now, when it comes to choosing between Nginx and HA proxy, they both have their strengths. Nginx is a versatile all-rounder, great for serving websites and caching content. But HA proxy is specifically built for high-performance load balancing, especially with TCP/UDP traffic. Okay, let's talk about load balancing. Essentially, it's like a traffic controller for your applications, making sure no single server gets bogged down while others are handling the load. We have a few different types of load balancers. You can find dedicated hardware appliances, software solutions running on servers, or even managed services offered by cloud providers like AWS and Azure. And importantly, there are different algorithms that decide how traffic is spread around. Round robin just goes server by server. Least connection sends requests to the least busy server. and weighted versions let you prioritize more powerful machines. Okay, let's talk about keeping things up and running, specifically high availability and disaster recovery. As a DevOps engineer, you need to think beyond just making your applications work. You need to make sure the stay working. The key here is redundancy, having multiple copies of critical parts so if one fails, another can take over. We're talking about automatic failover, like load balancers switching traffic seamlessly and databases replicating data. And don't forget monitoring. You absolutely need to be watching everything closely so you can catch problems before they affect your users. Finally, a well-defined disaster recovery plan or DRP is essential. It's basically the playbook for getting back on track after something major goes wrong. It includes things like how long it should take to recover RTO and how much data loss you can tolerate up here. Okay, let's talk about securing your applications with SSL/TLS. Basically, it's all about creating a secure connection between your website or service and anyone visiting it. Certificates are like digital ID that prove who you are online. They are issued by trusted authorities called certificate authorities. There are different types of keys involved, a public one shared with visitors and a private one kept secret on the server. We use CA like Let's Encrypt to get free certificates, but it's crucial to keep your certificates updated regularly and follow best practices for security. Okay, let's talk about identity and access management, or IAM, which is a really important part of being a DevOps engineer. Basically, IAM ensures that only authorized people can access your systems and data, like having a super secure gatekeeper for your entire DevOps environment. It's all about authentication, verifying who someone is and authorization, figuring out what they're allowed to do. We also talk about federation, which lets you use existing accounts from services like Google or Azure Active Directory to log in, making things easier for everyone. Strong IAM is key to keeping your systems safer and letting development flow smoothly. Okay, let's talk about cloud security. As DevOps engineers, we play a huge role in keeping our applications and data safe. We need to focus on 4 key pillars: identity and access management, making sure the right people have the right access, data security, encrypting everything possible and managing keys carefully, network security, building secure networks with the right rules, and finally, vulnerability management, constantly scanning for weaknesses and fixing them. A really important part of this is automating security using tools like Terraform or CloudFormation so we can apply these best practices consistently. And don't forget monitoring and logging. These give us crucial visibility into what's happening in our environment so we can quickly detect and respond to any issues. Remember, security isn't just about implementing tools, it's a continuous process. Okay, let's talk about keeping your secrets safe. Often, DevOps teams use a combination of tools for this, specifically HashiCorp Vault alongside Amazon Web Services Secrets Manager. Vault is like the central brain, giving you really tight control over who can access what and ensuring everything is encrypted properly. AWS Secrets Manager handles actually storing those secrets within your AWS environment, making sure they automatically rotate and get versioned for easy recovery if needed. Think of it as Vault requesting a secret from AWS, and then Vault providing it securely to your applications, a really common and effective pattern. Let's talk about SRE, which is really at the heart of DevOps. Think of it as building systems that are incredibly reliable and don't break. The key is setting clear goals, defining what good looks like for your services. Then you work to stay within an error budget, meaning you can tolerate a certain amount of downtime, but not too much. SRE emphasizes automation so you can do things faster and more consistently, and it's all driven by constant monitoring and feedback loops to catch issues before they impact users. Okay, let's dive into how we manage errors effectively in DevOps. We start with service-level objectives. These are the concrete goals you set for your services, like ensuring a high level of uptime or fast response times. Then, we use service-level indicators to track our progress towards those objectives. Think of metrics that tell us if we're on track. Finally, we introduce the concept of an error budget. This is essentially a tolerance level. It's the acceptable amount of errors you can have without breaching your SLO. It's all about proactively managing risk and ensuring a stable and reliable service. Let's talk about blue-green deployment, a really smart way to release new software without any interruptions. Basically, you have two identical environments, one live, the blue environment, and another that's ready for testing, the green environment. You deploy your updated code to the green environment, test it rigorously, then slowly start shifting user traffic over from blue to green. It's like a safety net. If anything goes wrong, you can instantly flip the switch back to blue without impacting users. This method significantly minimizes downtime and makes rollback super easy, giving you a lot more confidence in your deployments. Let's talk about canary deployments. This is a really smart way to roll out new features or updates. Basically, you deploy a small version of your app. Think of it as a canary to only a tiny portion of your users. Then you keep a super close eye on that canary, looking for any problems, slow performance, or unhappy users. If everything goes smoothly, you slowly ramp up the number of people seeing the new version. It's like testing the waters before diving in head first. This helps catch issues early and minimizes the risk compared to releasing something big all at once. Okay, let's talk about rolling updates and rollbacks. These are absolutely essential skills for any DevOps engineer. The core idea is deploying changes in small steps to minimize disruption. We start with continuous delivery, meaning we deploy frequently in tiny batches, like a canary release where you only expose the new version to a portion of your users initially. Then, constant monitoring is key. We need to watch metrics like error rates and response times closely. If something goes wrong during the rollout, we quickly trigger an automated rollback, reverting back to the stable version, ensuring minimal impact on our users. Okay team, let's talk about how we make our system super reliable through chaos engineering. We're going to look at Gremlin and Chaos Mesh, which are like the tools for deliberately breaking things in a controlled way. Gremlin is a distributed engine that lets us inject different kinds of failures, like simulating network problems or database slowdowns. It sends back real-time feedback on how these disruptions affect our services. Then we have Chaos Mesh. It's built to work with Kubernetes, making it super easy to define and run chaos experiments just using YAML files. Basically, by intentionally causing a bit of mayhem, we can find hidden weaknesses and strengthen our systems against the unexpected. Okay, let's dive into GitOps. It's a really cool way to manage your infrastructure. Basically, we treat everything as code stored in Git. Think of it like this: instead of manually pushing updates, we define exactly what our system should look like in Git, and then tools automatically make sure it matches the definition. It's all about declaring the desired state, automating deployments, and having a complete history of every change. We've got two major players here, Argo CD and Flux CD. Both are fantastic open source options for making this work. Okay, let's talk about code quality, super important part of DevOps. We're going to look at how we use static code analysis, specifically with SonarQube. Think of SonarQube as your automated code reviewer. It doesn't run the code, but it looks at the code itself and flags potential problems like bugs, security vulnerabilities, or just things that make the code harder to read and maintain, what we call code smells. It integrates really well with our CI/CD pipelines, so we can catch these issues early on. It provides a maintainability index, which is great for tracking improvements. Basically, by catching problems early, we save time and money in the long run. Okay, so let's talk about code coverage tools. They're super important for DevOps engineers. Basically, these tools help us see how much of our code is actually being tested. There are a bunch out there, like Cobra for Java, Istanbul or NYC for JavaScript, and gcov/lcov for C++. They give us reports on different types of coverage: branch coverage, line coverage, and even mutation coverage. Think of it like this: the more code covered by tests, the better. It helps us catch potential bugs and improve our overall quality. Okay, let's talk about API gateways. Think of them as the main entrance to your application's backend. They handle all incoming requests before they get routed to your individual microservices. A key job is routing, making sure each request goes where it needs to be. Then there's security. Gateways can add authentication and authorization, verifying who's asking for what and ensuring they have the right permissions. Rate limiting protects your services from being overwhelmed by too many requests at once. And sometimes, you need to transform data, like converting a request from one format to another. Services like AWS API Gateway, Azure API Management, and Con are frequently used. Okay, let's talk about deploying microservices. Think of it like building with Lego bricks. You have lots of small, independent pieces that need to work together. We use containerization, primarily Docker, to package each service and its dependencies so they run consistently everywhere. Then we need an orchestrator, like Kubernetes, to manage all those containers, automatically scaling them up or down as needed. A service mesh, things like Istio or Linkerd, can add extra layers of control and visibility between these services. When it comes to deploying, there are different strategies. Blue-green is a popular one, where you deploy the new version side by side with the old, and then switch traffic over when everything looks good. Canary releases let you test changes on a small group first. Finally, monitoring is *key*. We need tools like Prometheus to track metrics, ELK or Splunk for logging, and tracing systems to understand how requests flow through the whole system. Basically, we're constantly looking at the health of our services and making sure everything's running smoothly. Okay team, let's talk about getting microservices deployed quickly and reliably. The key is CI/CD, continuous integration and continuous delivery. Think of CI as automating the building and testing process whenever someone makes a code change. It's all about catching problems early. Then we have CD, which takes that tested build and automates the release to production. It's like setting up an assembly line for your software. We'll typically see stages like automated builds, unit tests, integration tests, deploying to staging, maybe some user acceptance testing, and finally, a smooth deployment to live production, using techniques like blue-green deployments to minimize downtime. Okay, let's talk about testing within DevOps. It's more than just finding bugs, it's about ensuring your system is solid throughout the entire process. We break down testing into 4 key areas. Unit testing, focusing on individual parts of the code to make sure they work as expected. Then we move on to integration testing, where we check how these units interact with each other. Performance testing helps us see how our application handles heavy loads and ensures a good user experience. And finally, security testing is paramount. It's all about finding vulnerabilities before bad actors do. Okay, let's talk about how DevOps engineers ensure their applications don't break under pressure. We'll look at 3 key tools: JMeter, K6, and Gatling. JMeter is a really mature, open source tool that's been around for ages. It's great for simulating lots of users hitting your website or app, and you can configure it to do almost anything. K6 is a newer player in the game. It's written in Go and focuses on being super fast and easy to use, especially if you're already familiar with JavaScript. It integrates really well into your CI/CD pipeline. And finally, there's Gatling, which uses Scale. It's built for handling massive loads and offers fantastic visualization capabilities so you can easily see how things are performing. Okay, let's talk about API testing, super important in DevOps. Postman is like the friendly face of API testing. It's a really intuitive GUI that lets you easily build requests, see exactly what the responses look like, and manage different environments for your API. Think of it as your go-to tool when you want to manually test an endpoint. Now, Newman is a slightly different beast. It's a command line runner that works with Postman collections. It's perfect for automation, especially in continuous integration and continuous delivery pipelines. You can simply run a collection using the Newman command, and it will execute all the tests automatically. Okay, let's talk about keeping our software secure throughout the development lifecycle, specifically with DevOps. A key part of that is adding automated security scans into our CI/CD pipeline. We've got a few excellent tools to choose from. First up, Snike is a really popular option. It focuses on open source dependencies and helps us spot vulnerabilities before they become problems. Then there's Aqua Security, which specializes in container security, making sure our containers are protected as they move through the entire process. Trivy by Aqua Security is great because it's lightweight and easy to add into our existing workflow, scanning images and files for potential issues. And finally, Claire, another tool from Aqua specifically designed to check Kubernetes clusters for vulnerabilities. Integrating these tools will give us ongoing visibility into security risks, helping us build more resilient applications. Okay, let's dive into container image scanning. It's a really important step in making sure your DevOps pipelines are secure. Think of your container images like little packages that hold everything needed to run an application. But sometimes, these packages have vulnerabilities, which are basically weaknesses that hackers could exploit. Image scanning tools automatically check for known security flaws, license issues, and even misconfigured settings within those images. Tools like Trivy, Claire, and Snike are popular choices. Trivy is particularly great for quickly checking your images during your continuous integration process. It's all about proactively finding and fixing problems before they cause trouble. Okay, let's talk about vulnerability and patch management. As a DevOps engineer, you need to be constantly on the lookout for weaknesses in your systems. We use tools like scanners to find these vulnerabilities, and then we assess how serious they are, what impact could they have if exploited. Prioritization is key. Then, we follow a process of testing patches first in a safe environment before rolling them out to production. Automation helps us make this much more reliable. And finally, ongoing monitoring means staying aware of new threats and promptly applying fixes. It's not enough to just patch. You need to understand where vulnerabilities come from and build security into your systems from the beginning. Okay, let's talk about release management. It's a really important part of DevOps. Think of it as the organized way we get updates out to our users. It all starts with planning, figuring out what needs to be released, how often, and even having a plan if something goes wrong. We break releases into stages like building the code, testing it thoroughly, getting it ready for production, and then finally deploying it live. Automation is super important here. Using tools to handle the process automatically reduces mistakes. And of course, we always have a backup plan, a rollback strategy just in case things don't go as expected. Okay team, let's talk about managing those inevitable incidents. Incident management is all about getting back up quickly when something goes wrong. First, we need to detect the problem. Our monitoring tools will flag anything unusual and send notifications. Then, it's time to figure out exactly what's going on and how serious it is. We triage the alert, pulling in logs and metrics to understand the scope. If a simple fix isn't enough, we escalate to the right experts. Once we solve the problem and get things back running smoothly, we don't just leave it there. A post-incident review helps us learn from our mistakes and prevent these issues from happening again. Okay, let's talk about alerting systems, a super important part of DevOps. We're focusing on how tools like PagerDuty and OpsGenie work together to keep things running smoothly when problems pop up. PagerDuty is really great at handling specific incidents, making sure the right people are notified with the right level of urgency and giving you detailed instructions on what to do. OpsGenie, on the other hand, is more about seeing the bigger picture. It helps visualize potential issues across different teams and services. You'll often find these tools working side by side, with OpsGenie triggering alerts that get sent to PagerDuty for a closer look. It's all about having the right system for each stage of an incident. Okay, let's talk about keeping your cloud bills under control. As a DevOps engineer, cost management isn't just an afterthought, it's a critical part of the job. The good news is there are several key strategies we can employ. First, always make sure you're using the right size instances for your workloads. Don't be over-provisioning. Then, investigate reserved instances and savings plans if you have predictable needs. Auto-scaling helps ensure that resources only use what they need when they need it. And if you've got fault-tolerant apps, spot instances can save a ton of money. Finally, don't forget to actively monitor your cloud spend using the provider's tools and implement robust tagging. It makes everything much easier to understand and optimize. Okay, let's talk about auto-scaling. It's a really important part of how DevOps engineers keep applications running smoothly and reliably. Basically, it's like having a smart resource manager in the cloud. The platform constantly monitors things like how busy your application is or users hammering at the servers, and automatically adjusts the number of servers needed to handle that load. It scales up when there's more traffic and scales down when things quiet down. Azure and Google Cloud all have their own versions of this technology called auto-scaling groups, virtual machine scale sets, and managed instance groups respectively, making it a common tool for DevOps professionals. Okay, let's talk about immutable infrastructure, a really important concept in modern DevOps. Think of it like this: instead of constantly tweaking and updating your servers, you treat them as completely new every time you deploy something. Why? Well, it drastically reduces problems with configuration drift, which is where things slowly get out of sync across different environments. It makes rollback super easy. If something goes wrong, you just revert to the previous working image. Plus, it's generally more secure because there's less for attackers to exploit. The core idea is build once, deploy many. You create a perfect base image or container and then use that as your foundation for every single environment you need: development, testing, production. Tools like Docker and Packer are essential here, along with things like Terraform and Ansible used carefully. Basically, if something in your configuration needs to change, you build a new asterisk image with the update and deploy that instead of modifying an existing one. Okay, let's talk about taking monitoring to the next level, specifically by integrating it into our infrastructure as code practices. Basically, we're treating our observability tools, like Prometheus or Grafana, just as code. This means using tools like Terraform or Ansible to build and set up those monitoring systems, ensuring everything is consistent and easy to replicate. We use templating engines and Git for version control so that changes are tracked and can be rolled back if needed. And crucially, we automate the deployment process, meaning when our applications change, our monitoring infrastructure updates automatically too. Finally, we can even apply policies as code using things like Open Policy Agent to enforce security and operational guidelines. It's about treating observability with the same level of care and discipline as our core applications. Okay, let's talk about resource tagging. It's a really important part of being a DevOps engineer. Think of tags as labels you stick on your cloud resources, like servers and databases. Why do we need them? Well, they give us incredible visibility into what's going on in our infrastructure. We can group things by environment, who owns them, or even the application they are running. It helps us with cost allocation, knowing exactly where money is being spent, and it makes automation much easier because we can target resources based on their tags. There are lots of tools to help with this, from your cloud provider's built-in features to dedicated tagging solutions. And the key is consistency. A well-defined strategy will pay dividends in the long run. Okay, so let's dive into how we can make our Ansible inventories really smart. Traditionally, we'd have to manually update a file listing all our servers. It's a pain when new servers are added or existing ones change. Dynamic inventory is the solution. Instead of relying on a static list, Ansible pulls information from places like CMDBs or Cloud Provider API. It constantly checks for updates so your playbooks always know exactly what's running and where. Think of it as Ansible automatically keeping its finger on the pulse of your infrastructure. Let's talk about custom modules in Ansible. Think of them as your secret weapon for taking automation to the next level. Sometimes you need an action or check that isn't built into Ansible's core library, and that's where custom modules come in handy. They allow you to extend Ansible's capabilities, create reusable code, and make complex logic easier to maintain. A custom module is basically a Python script, along with some metadata about it telling Ansible what the module does, what parameters it accepts, and what it returns. You'll also need a documentation file, which helps other users find your module on Ansible Galaxy. We'll cover the key components like the Python script itself, the metadata files, and how to document your module for easy sharing. Okay, let's talk about Terraform state. Think of it as the brain of your infrastructure. It keeps track of everything you've created and how it's all connected. It's super important to understand this because it ensures everyone on your team is working with the same information, leading to consistent deployments. There are two main types: local state, which is fine for small projects but gets messy quickly when teams collaborate, and remote state, which is stored somewhere like S3 or Terraform Cloud. That's the way to go. And always remember to version control your state file. Treat it like any other piece of code. Okay, let's talk about how Terraform keeps track of its work, specifically state locking and backends. Think of Terraform state as a record book of all the resources it manages. To avoid chaos when multiple people or processes are updating things at once, Terraform uses something called state locking. It prevents simultaneous changes to that same record, ensuring everything stays consistent. Now a backend is where Terraform actually stores the state file. Basically, it's memory. There are lots of options for backends like Amazon S3, Azure Blob Storage, or even Google Cloud Storage. Local storage is fine for testing, but you'll want something more reliable for production environments. Okay, let's talk about Terraform modules and workspaces. Modules are like building blocks for your infrastructure. They are reusable pieces of code that you can use across multiple projects. They help keep things organized and easy to maintain. Think of them as functions you can call repeatedly. Then we have workspaces. These allow you to manage different environments like development, staging, and production all within a single Terraform project without needing to copy and paste code everywhere. It's fantastic for keeping your configurations separate and making sure changes in one environment don't accidentally affect others. Okay, let's talk about taking our Kubernetes game up a notch. We've covered the basics of deploying applications, but now it's time to explore advanced Kubernetes operators. Think of these as automation superheroes for your apps. They handle everything from scaling and updates to self-healing, all without you having to manually intervene. Essentially, we're going beyond standard deployments and creating custom resources that represent our entire application. We'll define what those new resources look like, custom resource definitions or CRD, write the logic within the operator itself, often use and go and build controller loop that constantly monitors and adjusts things to match our desired state. It's all about automating the life cycle of your apps, making them more reliable and easier to manage. Okay, let's talk about managing secrets and config maps in Kubernetes. They're really important for keeping your applications secure and configurable. Secrets store sensitive information like passwords and API keys, and they're often base64 encoded. Config maps are used to manage non-sensitive configuration data, kind of like externalized configuration files. You can mount them as environment variables or volumes within your pods. It's really important to understand the difference. Secrets hold sensitive stuff, while config maps handle general configuration settings. Choose the right tool for each job. Okay, let's talk about ingress controllers. Think of them as the traffic managers for your applications running inside a Kubernetes cluster. They handle all incoming requests from outside the cluster and route them to the correct services. We'll be looking at two popular options, Nginx and Traefik. Nginx is a really well-established reverse proxy, and it's often bundled with an ingress controller. It's known for its flexibility and robust caching. Traefik, on the other hand, is a more modern edge router that automatically manages things like TLS certificates using Let's Encrypt. It's designed to be super easy to set up and keep running smoothly. It just works. So, which one you pick depends on your specific project requirements. Let's talk about how applications store data in Kubernetes. At its core, we have persistent volumes. These are like raw storage disks offered up to the cluster. Then, when an application needs a place to store things, it creates a persistent volume claim that's essentially asking for storage. Kubernetes then finds a compatible persistent volume and binds them together. Finally, storage classes come into play. They define how those volumes are created automatically, allowing you to easily manage different performance tiers or replication options. It's all about making things simpler. Okay, let's talk about load balancing. It's a really important part of DevOps. Think of it like this. You have lots of servers running your website or app, but they can only handle so much traffic at once. A cloud load balancer steps in and intelligently distributes all that incoming traffic across those servers, ensuring no single server gets overwhelmed and everyone has a smooth experience. We'll specifically look at AWS application load balancers. These are great for HTTP/HTTPS websites because they don't just send requests based on IP address, they actually understand the content being requested. We'll start by picking the right type of load balancer, then create it in the AWS console, defining target groups which group our backend servers together, and most importantly, setting up security groups so traffic can flow securely. Finally, we'll configure routing rules to direct users to the correct server based on what they're trying to access. Let's talk about cloud-native build packs. These are a really clever way to get your applications running in containers without you having to wrestle with Docker files. Essentially, they analyze your code, figure out everything it needs, libraries, runtime environment, and then build a complete container image for you automatically. It's like having a magic button that just works. Okay, let's talk about keeping things compliant as a DevOps engineer. It's really important that your infrastructure isn't just functional, it needs to meet security standards too. One key thing is infrastructure as code. By treating your servers and networks as code, you can track changes, automate testing, and make sure everyone's on the same page. We also need automated checks tools that constantly scan for potential problems. Then there's policy, is code, essentially turning security rules into code so they get enforced automatically. Finally, integrating security from the very beginning, or DevSecOps, is crucial to build resilient and secure systems. Let's talk about ensuring your infrastructure is always following the rules. We're looking at compliance as code, basically automating how we make sure things are compliant. Open Policy Agent, or OPA, is a powerful policy engine that lets us define how things should be, and Sentinel is a super helpful Kubernetes distribution for OPA. It takes those policies written in Go, which might seem a little complex at first, and uses them to check every time something happens within your cluster, like when you deploy a new application. Sentinel intercepts those requests, evaluates them against our policies, and then either approves or blocks the action. This means we get consistent compliance checks, reduce manual errors, and have much better audit trails. Okay, let's talk about logging in a distributed environment. It's a totally different ballgame than just logging one application. Because your services are spread out, you need to think carefully about how you collect and manage logs. You have two main choices: completely centralizing everything or adopting a more decentralized approach. Often a mix of both is best. A really important thing to focus on is correlation ID. These are like unique identifiers for each request as it moves through your system, making debugging much easier. And don't forget about log levels and filtering. You want to avoid drowning in irrelevant data. Finally, using structured logging formats like JSON makes querying and analyzing your logs a breeze. Okay, let's talk about observability, really digging into what's happening inside our systems. We start with metrics, which are like the big picture numbers giving us a sense of how healthy things are: CPU usage, memory, and response times. Then we move to tracing, which is all about following a single request as it moves through multiple services. It helps us find out where slowdowns or errors might be happening. Finally, we've got Jaeger and OpenTelemetry. Jaeger is a great tool for visualizing those traces, and OpenTelemetry is the newer standard that's unifying how we collect and export all this data, metrics, traces, and logs across different parts of our application. Okay team, let's talk about how we handle incidents, specifically how we learn from them. We do this through retrospectives, which are essentially post-incident reviews where the whole team gets together to discuss what happened, why it happened, and most importantly, how we can prevent it in the future. We use techniques like start, stop, continue to really drill down into what worked, what didn't, and what needs tweaking. Then, we do a root cause analysis (RCA), which goes beyond just fixing the immediate problem and tries to find out why it happened in the first place. Think of it as tracing back the cause until you hit solid ground. Finally, we meticulously document everything: the incident itself, our discussions, and the root causes identified. This documentation is key for sharing knowledge and preventing similar issues down the road. It's not about pointing fingers, it's about learning and building a better, more resilient system. Okay, let's talk about how automation testing fits into DevOps pipelines. Think of it as a critical step in ensuring we're building high-quality software quickly and reliably. We want to shift left, meaning we move testing earlier in the development process, not just at the end. There are lots of different kinds of automated tests, from unit tests that check individual pieces of code, all the way through UI tests that mimic how a user would interact with the application. Tools like Selenium and JUnit help us automate these tests. And the biggest benefit? By automating testing, we can catch bugs much faster, give developers continuous feedback, and ultimately build more confident releases. Okay, let's talk about DevSecOps. It's really all about weaving security into the fabric of our DevOps practices. It's not an afterthought. The core idea is to shift left, meaning we tackle security problems early in the development process rather than waiting until the end. We automate as much as possible, making sure that things like scanning for vulnerabilities and checking for compliance are handled automatically. Collaboration between developers, operations people, and security teams is absolutely vital. These guys need to work together seamlessly. And finally, we constantly get feedback on what's working and what isn't, continuously improving our security posture. Okay, let's talk about some common mistakes, what we call anti-pattern, that can really slow down your DevOps journey. One of the biggest is an output-only culture, where developers just focus on writing code and hand it off to operations. Another problem is when teams treat development and operations as separate entities, essentially throwing things over the wall. We also see a lot of issues with overly complex, undocumented scripts that become known as scripts of doom, and an unfortunately common tendency to do everything manually instead of automating processes. Finally, if critical knowledge is stuck only within a few people, that creates significant risks. It's called tribal knowledge, and it's something to actively combat. Okay, so let's talk about keeping those services running smoothly. Zero downtime deployments are a huge deal in DevOps. They basically mean no interruptions for your users. We've got a few different strategies we can use to achieve this. One popular method is blue/green deployment, where you run two identical environments, one live and one for testing. You deploy the new code to the staging environment, give it a thorough check, and then switch over the traffic. Another approach is canary releases, which involve rolling out changes to just a small group of users initially to monitor how things go before making them available to everyone. And finally, there's rolling updates, gradually swapping out older versions with newer ones as they come online. It's all about minimizing risk and maximizing availability. Okay, let's talk about container networking. It's a surprisingly important piece of the DevOps puzzle. Basically, containers are like little boxes that run your applications, but they need to be able to talk to each other and the outside world. The Container Networking Interface, or CNI, is how we achieve this. It's a standard way for container engines to interact with network plugins. Think of it as the rules engine for networking within your containers. We'll also look at things like network policies. These are really important for security, allowing you to control exactly which containers can talk to each other. Finally, if you're dealing with microservices, something called a service mesh can help manage all that complex communication. Okay, let's talk about multi-cloud and hybrid cloud strategies. They are super important for DevOps folks today. It's not just about putting applications in different clouds, it's strategically choosing the right cloud for the job. You'll need to consider things like which clouds are best suited for specific workloads, how you're going to keep everything securely connected. VPN and direct connections are key, and absolutely rely on infrastructure as code tools like Terraform to manage your environments consistently. Finally, robust monitoring across all those environments is essential to keep an eye on performance and make sure things are running smoothly. Hybrid cloud involves blending on-premises infrastructure with public clouds, giving you flexibility for phased adoption and meeting specific needs. Okay, let's talk about deployment strategies. We have three popular approaches: blue-green, canary, and rolling. Blue-green is a really straightforward one. You essentially create two identical environments, deploy your new version to the inactive one, test it out, and then switch all the traffic over. It's great for quick rollbacks if something goes wrong. Next up is canary deployment, where you release the update to just a small percentage of users first. This lets you gather feedback and catch any issues early on before they affect everyone. Finally, there's rolling deployment. This involves gradually deploying the new version across your servers, routing traffic incrementally. It's less risky than a full switch but takes longer to roll out completely. Okay, let's talk about CloudFormation nested stacks. These are essentially stacks within a stack. They're a fantastic way to build more complex infrastructure in a really organized and reusable way. It's like creating smaller building blocks that you can combine to create larger systems. The parent stack defines and launches the child stack, ensuring that everything stays consistent as you make changes. Think about deploying a web app. You might have separate stacks for your database, API gateway, and even the main application itself. This approach makes updates much easier, reduces complexity, and allows you to reuse those components across different projects. Let's talk about continuous integration and continuous delivery for infrastructure code. Basically, we're automating the whole process from getting new code changes to deploying those changes to your servers. Think of CI as a constant checkup. Whenever someone updates the code, it automatically gets built and tested. Then CD takes over, making sure those tests pass and that the new infrastructure is ready for release. Popular tools like Jenkins and GitLab CI help us manage these pipelines, ensuring our deployments are smooth and reliable. Okay, let's talk about monitoring our CI/CD pipelines. It's absolutely essential. You want to know exactly what's happening behind the scenes. We need to keep an eye on each stage of the process, building your code, running tests, and deploying it. Things like build times, how many tests pass or fail, and even if deployments are successful. Tools like Prometheus and Grafana can give you really detailed visualizations, while the ELK stack helps you collect and analyze all those logs. And don't forget to use the monitoring features that come built in with tools like Jenkins and GitLab CI. They are often a great place to start. Okay team, let's talk about getting our code from development to production. Version control is absolutely key here. Git is your best friend for tracking changes and working with a team. Think of branching as creating separate workspaces for new features or bug fixes. And those commit messages, they need to tell you why the change was made, not just what was changed. Now, when it comes to releasing that code, there are several strategies we can use. Blue/green is great for minimizing downtime, while canary releases let us test new versions with a small group of users first. Rolling updates are a solid option too. The best approach will depend on what we're building and how much risk we're comfortable with. Any questions? Let's talk about protecting our API. Rate limiting and throttling are key techniques for ensuring they remain stable and don't get overwhelmed. Think of rate limiting as a hard cap. Each user gets a certain number of requests within a set period, and after that they are blocked. This helps stop malicious bots or sudden spikes in traffic. Now, throttling is a bit more clever. It dynamically adjusts the request rate based on things like server load or user priority. It's like saying, okay, you can make a lot of requests right now, but if things get busy, we'll slow you down. Both are important for keeping your API healthy and available for everyone. Okay, let's talk about getting ready for DevOps interviews. A huge part of the process is demonstrating your coding abilities. This slide highlights 4 languages: Bash, Python, Groovy, and Go that you'll likely be tested on. Think of it as a mini coding blitz. Bash is great for automating common tasks like deployments and system administration. Python's incredibly versatile, especially when working with tools like Ansible to manage infrastructure. Groovy often pops up in Jenkins environments for dynamic scripting, and Go shines when you need to build really efficient DevOps tooling, particularly around containers and networking. Brush up on the fundamentals of each language, it'll give you a significant boost. Okay, let's dive into time series databases. These are a game changer for DevOps because they're built to handle data that changes over time, things like server metrics, application logs, or even network performance. Think of them as the perfect tool for monitoring your infrastructure and applications. Traditional databases can get messy when you're dealing with this kind of data, but TSDBs are specifically designed to handle it efficiently. We'll look at two popular options: InfluxDB, which is super easy to get started with, and Prometheus, a really powerful choice, particularly if you're using Kubernetes. Okay, let's talk about a really important concept in DevOps, the debate between mutable and immutable infrastructure. Think of it this way: mutable infrastructure is like patching an old car. You keep adding parts to it over time. It's faster initially, but eventually things get messy and unpredictable. Immutable infrastructure, on the other hand, is like building a new car every time you want an update. It's not always as quick to start, but it's much more reliable and easier to track what's happening. This choice has huge implications for how we build and manage our systems. Let's talk about scaling, how we make sure our applications can handle whatever traffic they throw at them. There are two main approaches: static and dynamic. Static scaling is like saying, we're going to always have 10 servers running regardless of whether they're being used. It's easy to set up, but can be a bit wasteful if demand drops. Dynamic scaling, on the other hand, uses tools like auto-scaling in cloud platforms to automatically add or remove resources based on how many users are actually hitting your application at any given time. That way you only pay for what you need and your app stays responsive. It's much more efficient. Okay, let's talk about how dashboards and reporting play a huge part in being a successful DevOps engineer. It's all about knowing what's going on with your systems, constantly. You'll want tools like Prometheus or Grafana to monitor things like CPU usage and memory, basically keeping an eye on the health of your infrastructure. Then you need log aggregation, think ELK Stack or Splunk, so you can sift through all those logs when something goes wrong. And finally, a good incident management system like Jira or ServiceNow helps you track problems, get them resolved quickly, and keep things moving smoothly. Ultimately, it's about turning data into insights that help you improve your processes. Thank you for watching.